Hi, here is a class of probability and stochastic process, and here's the video of homework 3 problem 1. Okay, let's check it out. Firstly, let's read the problem. Let probability of x equals to k equals to b multiply k multiply p to the k minus 1, and k equals to 1, 2 to the infinite. 0 less than p less than 1. The problem 8, find b so that the probability of x equals to k represents a probability mass function. Okay, let's solve this problem. Firstly, let's discuss a more general problem. We'll accumulate from k equals to 0 to infinite p to the k's equals to 1 plus p squared to infinite, which equals to 1 divided by 1 minus p. And let's differentiate both sides with respect to p. We get that accumulate from k equals to 0 to infinite k multiply p to the k minus 1, which equals to 1 divided by 1 minus p to the 2, which if we multiply p to the two sides, we get that from k equals to 0 to infinite k multiply p to the k's, which equals to p divided by 1 minus p squared. Okay, let's differentiate both sides. Continue with respect to p, which equals to k equals 1 to the infinite k squared p to the k minus 1, which equals to 1 plus p divided by 1 plus p to the third, which can be changed to k equal to 1 to infinite k squared p to the k's equals to p plus p squared divided by 1 minus p to the third. Let's differentiate both sides with respect to p, which outcome is k equals 1 to infinite k to the third p to the k minus 1, which equals to 1 plus 4p plus p squared divided by 1 minus p squared. Okay, let's take a look at the problem 8, which find b. We can get from here that accumulate from k equals to 1 to infinite k multiply p to the k minus 1, which equals to 1 minus p squared 1, and which equals to from k equals to 1 to infinite b kp to the k minus 1, which equals to 1. So we can get that b equals to 1 minus p squared. And let's discuss the problem b. Find ex. We can get that ex is equals to accumulate from k equals to 1 to infinite k multiply p x equals k, which equals to k equals to 1 to infinite b k squared p to the k minus 1. We can find from here that, and we know that b equals to 1 minus p squared. So we can find from here that k squared p to the k is so we can know that here is b multiply 1 plus p minus 1 minus p to the third, and we know that b is 1 minus p squared. So the output is the outcome is 1 plus p divided by 1 minus p. So we know the ex, and the problem say it find ex squared. We know from here that e squared equals to k equals to 0 to infinite k squared p x equals to k, which equals to k equals to 1 to infinite b k to the third p to the k minus 1. And we know that k to the third p to the k minus 1, which is here is to the fourth, yeah. So which is 1 minus p squared multiply 1 minus p to the fourth, 1 plus 4p plus p squared, and the outcome is 1 plus 4p plus p squared divided by 1 minus p squared. So yes, we know that here is the e x squared. And okay, let's discuss the problem D, which let's find x squared minus ex squared. Yeah, so it's a outcome of problem C minus the outcome of problem B, the squared problem B. So the outcome which is obvious. And let's discuss the problem E. Let P equals to 1/3. Find the conditional probability mass function. Probability of x equals to k when 2 less or equals to x less or equals to 5. Okay, we know that p, which equals to 1 minus p squared, so the which is 2 divided by 9. And the probability of x equals to k, which equals to b k and p to the k minus 1, k equals to 1 2 to infinite, and here p equal to 1/3. So let's calculate x equal to k when 2 less or equals to x less or equals to 5, which we can write it as the probability of x equals to k and 2 less or equals to x less or equals to 5 divided by accumulate from k equals to 2 to 5, the probability of x equals to k, which equals to the probability of x equal to k 2 less or equals to x less or equals to 5 divided by k equals to 2 to 5, 4 divided by 9, which is, yeah, and k and 1/3 to the k minus 1. Yes, and all the outcome is equals to 0.5377 and 4 nice multiply k multiply 1/3 k minus 1 when k equals to 2 to 5, and when the k equal to other number, so the outcome is 0. Yes, here is the problem 1, and we have solved it. Thank you.